Today we will be reviewing gas laws and applying this knowledge with two practice challenge problems. The specific concepts we will be covering are Boyle's law, Charles's law, Avogadro's law, and ideal gas law. Boyle's law describes the relationship between the pressure and volume of a gas. This law states that the volume of a fixed quantity of a gas is inversely proportional to the pressure of the gas if the temperature remains constant. The relationship can be described in an equation like this. Basically, as the volume of a gas increases, the pressure of the gas decreases, and vice versa. Charles's law describes the relationship between the volume and temperature of a gas. This law states that the volume of a fixed amount of gas is directly proportional to its temperature if the pressure remains constant. This relationship can be described in an equation like this. Basically, this means that as the temperature increases, the volume of the gas also increases. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal numbers of particles. At standard temperature and pressure, 1 mole of any gas has a volume of 22.4 liters. At other temperatures and pressures, the volume and number of moles can be described in this equation. Basically, this means that if the number of particles in a gas increase, its volume also increases. Standard temperature and pressure, abbreviated as STP, is 1 atmosphere and 27.3.15 kelvins, which is 0 degrees in Celsius. Ideal gas law. Ideal gas law is a general law that can be used to calculate the value of an unknown variable in a gas if we know 3 variables of that specific gas. It is written as PV equals nRT. When using ideal gas law, we must use kilopascals or atmospheres for pressure, liters for volume, moles for N, and kelvins for temperature. And R depends on whether we are using kilopascals or atmospheres. When using kilopascals, R is 8.314. When using atmospheres, R is 0.0821. Now we will move on to practice problem number 1. Okay, so the first step for a problem like this is determining which gas law we have to use. And you can see, since we have 3 variables for this, that we're probably going to be wanting to use ideal gas law, which is PV equals nRT. So then let's just start. And then we have to identify what we need to find. So we need to find mass. So that it's probably going to be moles. So N. So now we just have to set up the equation and get to solving it. So pressure is going to be 1.08. Volume is, where's volume? 2. And then this is what we have to solve for. And then R would be 0.08821 because we're using atmospheres. And then for temperature, it's 15, but that's 15 degrees Celsius, but we have to convert it to Kelvin. So we're going to add 273.15. So then we'll get what we need, which is 288.15, because that's in kelvins. We have to use kelvins. So then let's just solve. So 1.08 times 2. And then you should get 0.09 0.14. And then it's asking us to find the mass, so that's me in grams. So this number right here, right now, is in moles. So we're going to have to convert that over. So we're going to have to use the molar masses of carbon and hydrogen. So the molar mass of carbon is around 12.01 and hydrogen is 1.008. So we're going to multiply hydrogen by 6, carbon by 2. And then we're going to add those together to get our molar mass for ethane gas. So if we do that, it's 24.02 and then 48. And then we add them together. We're going to get 30. So then we divide this number. We'd multiply this number. Yeah, we'd multiply this number by 30.048. And we're going to get about 2.75 grams. So the mass of ethane in this flask is 2.75 grams. Just go over the steps one more time. We use the ideal gas law to find the mass in moles, and then we're going to convert that to grams using the molar mass of the ethane gas to get the amount in grams. Okay, so now second problem, how many moles of helium gas would be required to fill a 22-liter container at a temperature of 35 Celsius and a pressure of 3.1 atm? So again, we can identify that this is ideal gas law because we're given three variables, and we're just looking for the fourth. So do it again. PV equals nRT. So pressure's gonna be 3.1. Volume's gonna be 22. And then we're going for moles. And then R would be 0.0821 again because we're using eight atmospheres. And then again, we'd have to convert Celsius. So we have to add 273.15, so it'd be 308.15. So then let's do the problem real quickly. And then you should get approximately 2.7 moles. So that's it. This one's a lot simpler. So